Okay, so here we have a SCARA robot, and we have to do the forward kinematic analysis. We have to generate the forward kinematic equations for this. So the rules for this are simple. We first have to identify the parts. So first step is to identify the parts. So let's call this as the part 0. And this whole part, this bottom and the top, both parts move together, so as a single object. So this total link is called as link number 1. This link is called as link number 2. This link is link number 3, and finally this last link is able to rotate about this axis, so this is called as link 4. This is the gripper, you can say. So now we need to identify the axis lines. So first axis of rotation is going around here. This is the first axis of rotation. Then we have the second axis of rotation around here, and then the third axis, you could say that it just passed through right here. Fine. So these are the three axes about which rotation is taking place. Once the axes are identified, we can just go ahead and mark out the Z axis. So first, right here we will mark out the Z0. This is where Z0 will mark, and then at the end of link number 1, this is the point where, okay, so this has to be pointing downwards. So this is Z1. And then over here at the center of this, we will have the Z3. And then here at this point over here, this as well will be pointing down. We will have Z. Okay, sorry. This one is Z2. And at the center of this over here, the pointing down will be Z3. And then finally at the end of this end effector, this is where we have our final point, that is Z4. So after marking the Z axis, now is the time for us to take the X axis. For this particular case, I'll take X axis in this particular direction, X0, and then okay, so here I'll try to take it parallel to the previous case. As far as possible, we have to maintain parallel directions. So this is X1, and then here as well I'd like to keep it parallel to the previous case. So this is X2, and then again I want to keep it parallel, go on keeping parallel. So X3, and finally again this is parallel, so this is X4. So now at the intersection of X and Z axis, we will get the origin. So this is origin 0, and then this here is origin 1, this here is origin, okay, where do I write, origin 2, this here is origin 3, this here finally we have origin number 4. Then we can find the y-axis by using the X and Z. Okay, so y-axis for this, it's going to be pointing in this direction, so this is y0. Then because this is in this direction, so y will be pointing in this direction, this is y1. Then once again the y will be moving at this particular direction, y2. Then again, I guess because all these coordinates are in the same direction, this is going to be the direction for y coordinate. Fine, so y4, and so on. Now we need to find the temporary points. In order to find the temporary points, that is Bn, we have to find the intersection of previous z-axis with the current x-axis. Okay, so previous so previous z-axis with the current x-axis. So if you want to find B1, if you want to find b1 will be located at the intersection of previous z-axis and the current x-axis. So let me take a line straight here. Fine. So that is our intersection point. So this here, right here, is the point b1. This here is the point b1. And then for b2 we have to take x2 and intersection with z1, that is over here. So this here is b2 as well as o1. Then okay, so current x and previous z, guess that's correct. Fine. Then for b3 we have to take x3 and previous z, that is there. So b3, okay, current x and previous z, that is b3. And then again here x4 and z3 intersect here at this point, that is b4. O4 and b4 come at same place, o3 and b3 come at same place. b2 is over here overlapping with o1, and b1 is here, which is not overlapping with any of the axes, any of the origin points. So now it's time for us to take all the variables. There are a total of 4 variables, and let's take this right here and place it here. So this will be helpful for us to take the points one by one the proper way. So we'll of course have four more set of these points, d4, a4 and alpha 4. This we'll have to write down later. So let's go ahead and do this. Now for d distance is the distance between previous origin and the current bn. So previous origin, that is origin n minus 1, and current b, that is bn. Okay, then same way, if you want to find the point an, that is bn an, that's the distance. So an is bn an. bn o1, sorry, bn o1. So this is the convention we need to follow. So let's go ahead and try to find out all these points. So o1 is the rotation about z0. So about z0, it's having a rotation because it's pointing upwards. It's going to be rotating in this direction. So this angle is theta 1, and theta 1 is a variable. So theta 1 is a variable. And coming to d1 is the distance between x1 and x0. So x1 and x0, this is the gap that we have, and that gap will remain constant. So we have d1, which is a constant, and it, of course d1 we have to call it as o0 b1. So distance between o0 and b1, that's the distance d1, which is constant. And coming to a1, we have distance between b and o1, so that is b1 o1. That distance is again constant. So b1 o1, that distance is constant. Let's call it as a1. So this is another constant. Then we have angle alpha 1. Alpha 1 is the angle between z1 and z0. So between z0, which is pointing up, and z1, which is pointing down, we have an angle of 180 degrees about x1. About x1, it's rotating by 180 degrees. So we can call it as pi as the angle, and it's a constant. Then coming over to theta 2. Theta 2 is the rotation about previous z-axis, that is z1 axis, and because it is pointing in downward direction, this will go in this particular direction, and that is a variable angle. Let's call it as theta 2. So theta 2 is a variable angle. Then about d2 is the distance between x1 and x2. X1 and x2 both are overlapping, so the distance is 0. Of course we can also name the point. D is the distance between previous origin. So O1 and B2. O1 and B2 are both overlapping, and hence its value is equal to 0, and of course this is a constant. Then coming to A2 is B2 O2, that is the distance. So B2 to O2 you can see we have a constant distance, that's distance A2, and it's a constant. Then we have to measure alpha 2. Alpha 2 is the angle between Z2 and Z1 about X. They are both parallel, so the angle is 0, and it's a constant. And then we have theta 3. Theta 3 is the rotation about Z2. Rotation about Z2. So there is no rotation going about here between the two. This one, the rotation, the relative motion between 2 and 3 is purely sliding, so we don't have to take any rotation. So we will keep this as 0, and it's a constant. And coming over to D3 is the distance between previous origin, that is O2, and current point, that is B3. So distance between O2 and B3, you can see that's a distance which is varying. So this distance here, it keeps moving up and down, so that's why we can say that it's a variable, and let's call it as D3, and it's a variable. And then coming to A3 is the distance between Z3 and Z2. Z3 and Z2 are overlapping each other, so that's 0, and it remains constant. Alpha 3 is the angle between Z3 and Z2. Z3 and Z2 are parallel, so it's going to be a 0 angle, that's remaining constant. Then theta 4, as we discussed, it's the angle about Z3. So about Z3, is it rotating? Is the fourth link rotating about Z3? Yes, it's rotating about Z3, and that angle we will call it as a variable. Then D4, it's a distance between previous X. So current x-axis and previous x-axis along previous z-axis, that is Z3. So in the direction of Z3, we have to see the distance between X3 and X4. Between X3 and X4 along X3, we can see there is a distance, but that distance is going to remain constant. So this is a constant. So let's call it as D4, and we can also write it as previous origin and current point. So O3B4 distance, that remains constant. Okay, so it's a constant. A4 is the distance between current Z and previous Z axis. So current Z axis is Z4, previous Z axis is Z3, and we have to measure this along the current X axis, that is X4. So measure the distance between these two axes, Z3 and Z4, along X4. Because these two are overlapping, that distance is going to remain constant at 0. And finally, alpha 4 is the angle. So angle between Z axis, the current Z axis and previous Z axis, about the current X axis, that is X4. So X4 and X3 are again parallel, so this angle is going to remain 0 and constant. So that's it. These are all the parameters that control our robot. So we can just put them all in the table neatly over here. So we can just put the links here. Then we can just put all the values. Let's put theta first, followed by d, and then okay. So we can just call it as n, and then alpha n. Okay, fine. So let's put them in this table. So we have link number 1, we have link number 2, we have link number 3, and we have link number 4. So total of 4 links are there here with us. So total of 4 links are there here with us. So all these we have to put it in here. So theta 1 is a variable. So theta 1 is a variable. You can just put a v at the top there. And theta 2 is also a variable, so theta 2 is a variable. Theta 3, you can see it's fixed at 0. Theta 3 is fixed at 0, so just put it as constant. And then theta 4 is again a variable, so theta 4 is a variable. So that's about the first one. Now about the distance, d. So d1 is value that is fixed at constant. It could also be 0 if both the origins are overlapping. Then we have for the link 2. For the link 2, the d value, that is d2 value is 0, you can see here. So that's a constant here, so we have this as constant. And then for link 3, that is d3, we can see this is a variable, so d3 is a variable. And coming to d4 is a constant. d4 is another constant. So that's about the values of d. And let's take the values of a one by one. So a1 value is constant, and we have a2 value is also constant, and then we have a3 value is 0, which is fixed at constant, and then a4 value is also 0, that is fixed at constant. Okay, and finally we have to take alpha values. So alpha 1 is equal to pi or 180 degrees, 180 degrees. You just put r here, pi or 180 degrees. Then alpha 2 value is equal to 0, it's fixed at constant. This is also fixed at constant. And alpha 3 is 0, that's again a constant. Alpha 4 here is again a constant, and it's equal to 0. So these are all the parameters, and we need to use these parameters we need to use in the equation, and we should be able to get the final compound transformation matrix for this. So how to remember the transformation matrix? That goes somewhat like this. So we have c theta, yes theta. So c theta, yes theta, 0, 0. And then here cos becomes sine becomes cos. Over here it remains the same, sine and cos. And then we get here cos alpha and sine alpha, and we get sine alpha and cos alpha. And then we get a cos theta and a sine theta. The cos changes to sine changes to cos. Okay, cos changes to sine and back to cos. Sine changes to cos and back to sine. And here we have cos. For alpha we have cos remaining same here and it is changing here. Same way sine alpha is remaining same here and changing here. Here we don't have any angle, we just have d. These three values remain 0. This is always fixed at 1. So this is the compound transformation matrix for the nth link. So the compound transformation matrix for the nth link. Fine. So here theta value and alpha value we have to take it as n. A value is also n. So we have to put n value everywhere. So n and n. So all these values are for the nth link. Fine. So that way we will have to find the transformation matrix for first link. Okay. So that we get by substituting all the theta values. The theta 1, alpha 1, all these d1, a1, all these if you substitute you will get a1. And same way we have to find a2, then we have to find a3 and a4. and multiplying with all these, we will get the overall transformation matrix for the SCARA robot. So this is how the forward kinematics is going to work. So the forward kinematics is going to work. So I hope you have understood this. I'm creating this video mostly for reference later, because it takes a lot of time for us to decide the conventions, and different books use different conventions, and that's the most difficult part to revise robotics whenever we come back to this and start thinking about this. And that's it for this video. And another video, maybe probably we'll do more on another robot. Fine. So thank you.